this is for those who missed our previous class. Okay, so first of all, this is the course synopsis for the class. So the course will introduce students to semiconductor devices, amplifiers, and basic concept in analog electronic, includes the basic structure of electronic devices, their characteristics and circuit applications, and the goal of this course is to develop excellent understanding of the device's operation for students to be applied in analog and digital circuit design. So basically this is what the course will cover. So next, these are the chapters of the course, right? So you can find more details about the week and chapters that covered in this course in course information that I have provided in your e-learning website. But what you have to remember that in week 6 we're going to have test 1, and week 11 there will be another test 2 before your final examination week, which is on week 17 to week 19, right? So the class will be every Monday 12 to 1 p.m. for 1 hour. So basically on this hour we will do tutorial, discussion, and if there is quiz, we're going to do quiz or review on Monday. But as it seems that some of you have clash on Monday, so I will try to push the quiz to be on Tuesday, inshallah. So on Tuesday we're going to have another class which is more to lecture around 8 to 10 a.m. Alright, for 2 hours class, and then mostly all the notes, assignments, and information about the class I will update through the e-learning website. And please always look on the e-learning website, alright? And you can contact me through my emails, or my room, or my office number. And nowadays I already created the WhatsApp group, and you can also contact me through the WhatsApp groups. Okay. So on chapter 1, in chapter 1 we will cover about semiconductor materials, and inside this chapter we will learn about introduction to electronic devices, atomic structure and material classifications, silicon and germanium structure, semiconductor doping and covalent bonding, and conduction in material. I think most of these topics you have covered or you have learned basically during your high school, and we will learn. We will look into deep in this chapter. So today's we will learn about only these 2 topics, about introduction to electronic devices and atomic structure and material classifications. Okay, what is the learning outcome from this topic? Okay, you will understand more about what is electronic device. You will able to describe the structure of an atom, and you should able to define what is atomic number, right? So what is electronic device? So electronic device is a component for controlling flow of electrical currents that is created in electronic circuit, with particular function. So each components, they have their own function. So the combination of all electronic devices, we call that as integrated circuit. So usually these components, these electronic components is small and it can be grouped together. Okay, so when you group it together, it is called integrated circuit. Okay, as you can see inside your CPU or any other electronic devices. So there are lots of examples of electronic devices. Here are some of the examples. Okay, for example, your smartphone. Now everyone has used a smartphone, computer, your laptops, your television. So all of that devices are electronic devices. Inside that, they have electronic components, yeah, electronic devices. So most of electronic devices, yeah, or electronic components, it is made of semiconductor. So we're going to look about what is semiconductor materials. Okay, so semiconductor materials is an elements which have a conductivity between good conductors and non-conductors or insulators, right? So non-conductors is also known as insulator. So semiconductor materials usually it is in the middle. It is between good conductors and also good non-conductors. It can be both. Okay, it depends how you want to apply these materials, right? So normally the materials, right, are germanium, silicon, okay, which is an elements, right? And also it can come with a combination of two different elements, which is like gallium arsenide. Okay, so these three materials are widely used in construction of electronic devices, right? So most electronic components is made from germanium, silicon, and gallium arsenide. So all of this, yeah, it's all begin from an atom. Okay, you should know this. Yeah? Everything begin from an atom. So what is atom, right? So atom is an element. Okay, it is an element which cannot be broken into another substance. It is the smallest. It is the simplest substance, right? So it cannot be broken into another substance. Okay, it is made by one type of atom. Okay, all right. So example of atom like oxygen, hydrogen, helium. So all of that is an atom. All right. So we're gonna look into detail. What is element? Did you still remember what is element? Okay. Element. Each element has a different number of protons. Right? Each element has their different number of protons. They have their own number of protons. There are no two elements that have same number of protons. Yeah. So the atomic number equals, yeah, the atomic number equals the number of protons in the nucleus. So you know, inside an atom there is protons, there is nucleus, there is also electrons, and there is an orbit, right? So what is protons? Okay, protons is a positive charge, right? Positive charge of an atom. Alright, so the atomic number equals the number of protons in the nucleus, which is the same as number of electrons in an electrically balanced. What is electrically balanced? It means in a neutral condition. Okay, in a neutral condition, the number of protons, the number of positive charge equals to the number of negative charge. So in this situation, we called it as electrically balanced neutral atom. So neutral atom, usually the number of protons and the number of electrons is same. So the atomic number for an element does not change, and no two elements have same atomic number. So it's just like a sports team. Yeah? In a sports team, each of the players have their own number. So there are no two players wearing or sharing the same number. Okay, so same as elements too. Yeah, all elements that arrange in periodic table. Remember about periodic table? Okay, so all elements that arrange in periodic table is based according their atomic number. So this is to revise your periodic table. So this is the periodic table, right? So these are groups 1, okay, then group 2, okay. So this is the atomic number, Okay, this is the atomic number. This is elements, the name of element. Okay, name of element. Right, so for H, it is hydrogen. He means helium, right? So when we said about atomic structure, it is familiar, it is famous with Bohr model. Okay, this is a very basic model of atomic structure, which is Bohr model, right? So Bohr model has been introduced by Niels Bohr, right? This is for additional information. Okay, it is introduced by Niels Bohr on 1913. Okay, so this is example of Bohr model. Okay, so what is Bohr model? It is a planetary type of structure that consists of central nucleus. It has a central nucleus surrounded by orbiting electrons. So this is nucleus. Inside the nucleus, there is neutron and protons. Okay, nucleus contains of protons and neutron, and outside there, okay, the nucleus is surrounded by orbiting electrons. Okay, so each electrons has their own orbit. So what we call as orbiting electrons. Okay, so nucleus consists of positively charged particles, which is protons, and uncharged particles called neutrons. Yeah? So orbitals is place where electrons located in an atom. So what is electrons? Electron contains of negative charge, and it is orbiting the nucleus at certain distance. Okay, so at certain distance, they have their own distance. For example, for this electron, they have their own specific distance. For these electrons, they have their own specific distance. So each electrons, they have their own distance based on energy levels. Okay, we're going to look more details about energy levels in another class. Okay, in next class. So these are example of Bohr model for hydrogen atom and helium atom. Okay, so hydrogen atom, it only contains one atomic number. So it means that it has one electron and one proton, right? So for helium, the atomic number for helium, it is 2. So it contains of 2 electrons and 2 protons. Okay, so electrons in orbits around the nucleus. Okay, it is around the nucleus. So if you can look into this image here, there is like a tails behind the electrons. So what is tails symbolize? Okay, the tails on the electron indicates the motion. Okay, a motion or movement of the electron. So it indicates that this electron is actually moving at the orbit. Okay, so there is no tails at nucleus and protons. So it means that nucleus and protons is not moving. Only electrons is moving. Okay, so the direction is based on the orbits, right? So it's just like our planets, yeah? So we're going to look more into details about electrons and shells. So only discrete or separate and distance values of electrons' energies exist within atomic structure. Okay, so in each atomic structure, each electrons have their own energies. Okay, and the distance or between each electrons to nucleus is depending on how much energies that they have. Okay, so therefore electrons must orbit only at discrete distance. Okay, discrete. What is the meaning of discrete? At separate and specific distance. Okay, at discrete distances from the nucleus. So each discrete distance from the nucleus corresponds to a certain energy level. So for these electrons, they have their own specific energy levels. For these electrons, they have their own specific energy levels. Yeah, so each orbit, yeah, have their own energy levels. In an atom, the orbits are grouped into energy level known as shells. So, okay, so this each energy levels is grouped into a specific shell. Okay, a given atom has a fixed number of shells. So each shell has a fixed number of electrons. Okay, so I think you have learned this during your high school. Okay, shell number 1 can only consist of 2 electrons. Okay, still remember, shell number 2 can consist how many electrons? Let's look next. So the maximum number of electrons, which is Ne, that can exist in each shell of an atom is a fact of nature. Okay, it is a fact of nature and can be calculated by the formula of Ne to n squared. Okay, I think it is very easy for you to memorize shell 1 can contain how many number of electrons. But if the shell is getting bigger, so it's very hard for you, it's very difficult for you to remember how many electrons can consist in those shells. So if you want to know how many electrons can consist in further shell, okay, in the next shell, you can use this formula, okay, where n is referred to the number of shells. So if you want to calculate shell number 8, for example, so Ne equals to 2 shell number 8, then squared, right? So the maximum number of electrons that can exist in the innermost shell, which is shell 1, okay, innermost shell, is 2, right? Is 2. All right, next, let's look what is valence shell and valence electron. Okay. Valence shell and valence electron. Electrons that are in orbits far, okay, the far orbit from the nucleus have higher energy. What is the meaning of higher energy? It means that the electrons which is located far from the nucleus, they can move very freely because they are more energetic. Okay, why? Because they are far from the nucleus. Okay, the attraction between the electrons and the nucleus is less. Okay, so these electrons are less tightly bound to the atom that can closer to the nucleus. This is because the force of attraction. Okay, this is what we call I explained just now. The force of attraction between the positively charged nucleus and the negatively charged electron decrease. Okay, decrease with increasing distance from the nucleus. Okay, so for example, this is nucleus. This is the first shell. This is the second shell. This is the third shell. Okay, this is the third shell. So shell number 3, electrons in shell number 3, shell number 1, and shell number 2. Electrons that exist in shell number 3 is less attracted to the nucleus compared to electrons in shell number 1. Okay, because the distance of electrons with nucleus at shell number 1 is lesser. Maksudnya dia lagi dekat. Okay, the distance is nearer, so it means that the force of attraction is stronger compared to electrons that exist in shell number 3. Okay, so the outermost shell is known as a valence shell. Okay, so this shell, the outermost shell, we know it is known as valence shell, and the electrons that located, okay, in the outermost shell we called as valence electrons. All right. So in general, the number of valence electrons of a representative element is equal to the group number. Okay, for example, I show you again the periodic table. For example, for group number 1 here, okay, all these elements, the outer shell is 1. The number of valence electrons is 1. So it is known as group 1. All right. Next, let's look into details about energy band. This is just introduction of energy band. I will explain more detail of energy band in our next class. So this is energy band. Okay, so each shell, they have their own energy band. So there are two types of energy band. We have conduction band and we have valence band. Okay, between conduction band and valence band, we call this energy gap. All right. So in energy gap area at this region, there are no electron exist in this area. Okay, so valence electron just now, the outermost electrons, the outermost electrons, okay, is located at valence band. Okay, valence band. Okay, so valence electron, all those valence electron is actually inside the valence band. Okay, so so the energy gaps here, okay, also represent the amount of energy that a valence electron must have in order to jump from the valence band to the conduction band. Okay, so let's say that this this valence electron, if they want to jump, okay, if they want to move freely, okay, they need to jump from the valence band. These electrons need to jump and goes into the conduction band, right? So if the bigger the energy gap, the bigger the energy of valence electron required in order to jump to conduction band. Okay, so for insulator, okay, for an insulator, the energy gap is bigger. Okay, the energy gap is bigger. So it means that this valence electrons needs lots number of energy in order for the electrons valence to jump into conduction band. For a semiconductor, the energy gap is not very big, compared to insulator. And for conductor, okay, the energy gap is, there is no energy gap actually for conductor. So it is overlapping. The conduction band and the valence band is overlapping. Okay, so it means that all the electrons in valence band can always freely move into the conduction band. Okay, so here are the example of energy gap value. For silicon, the energy gap value is 1.12 eV. For energy gap for germanium, the number is 0.67 eV. What does that mean? It means that silicon energy gap is bigger compared to germanium. All right, silicon energy gap is bigger compared to germanium. So it means that valence electrons of germanium can easily move to the conduction band compared to silicons. Okay. So in next class, we're going to look more into the details about material classification, silicon and germanium structure, semiconductor doping and covalent bonding, and conduction in materials. Right, so any questions that you want to ask related about this chapter, you can always email me or you can message me. Right? Thank you. Macam mana tak nak ni? Macam mana tak nak yang record ni? Macam mana tak nak yang record ni? Tak boleh kan? Nak yang record, nak yang record.